welcome again to the channel. Today's problem is question number 7, taken from paper 2 of 2020. I've written the question on the board, and on this other side of the board, I've got a little sketch showing the graph of y is equal to tan of x plus cos of x, which goes together with question B. Now let's read the question. Show that tan squared x plus cos squared x is equal to sec squared x plus half of cos of 2x minus half. And hence, find the exact value of the integral of 0 up to pi over 4 of tan squared x plus cos squared x with respect to x. Question B says, find the volume of solid produced when the region shaded in green is rotated about the x-axis. They are talking about this region I have shaded here in green. The graph is in blue, and the boundary of the area is the value of x, pi over 4, and the y-axis. And so what they are talking about here is what is the volume produced when you rotate this region a complete revolution about the x-axis. In other words, as if the x-axis was an axle. So when you rotate this thing one complete circle, it produces some kind of a solid, and we need to find the volume of that solid here. Now in this blue box, I've just indicated the tasks that we need to carry out. Task number 1 is to prove the trig identity here, that one there. Task number 2 is to integrate this, which I've written in red here. And thirdly, we need to calculate the solid of revolution. This is the solid that I was talking about, which is produced when this is rotated one complete revolution about the x-axis. Of course, there's nothing to stop anyone from rotating this about the y-axis. But in this case, we are looking at the solid produced when we revolve it around the x-axis. So what are we waiting for? Let's get cracking. We're going to start, of course, with task number 1, proving the identity over there. I don't think we need this little sketch here. We can get rid of it. If at any point we need it, we'll just draw a little sketch like this somewhere at the corner there. So let's clear the board and start with our trig identity. This ink is a little bit stubborn, but it will eventually clear. Okay, so it says there, tan squared x plus cos squared x is equal to sec squared x plus that one there. So first of all, what we have to consider here is, of course, when you are asked to prove a trig identity, you are free to start from any direction proceeding in the other direction. You can start from this direction going in this direction, or you can start from this going to this direction. In this case, I believe it is much easier to proceed from left to right. Now, look at that here. Everything is expressed in terms of sec squared x and cos of 2x. So what we need to do is to look at these two guys and see how each one of them can be converted into either this or that. Now let's start with tan squared x. We know, everybody knows that tan of tan squared x plus 1 is equal to sec squared x. It's equal to sec squared x. So therefore, it means that tan squared x is equal to sec squared x minus 1. So we can write, this implies tan squared x is equal to sec squared x minus 1. Okay? What about cos of 2x? Cos of 2x, we know cos of 2x is equal to cos squared x minus sine squared x. Of course, we can get rid of the sine there because we don't see it appearing there. So this can be written as cos squared x minus brackets 1 minus cos squared x, because sine squared x is 1 minus cos squared x. So this becomes a plus, and we end up with a 2 cos squared x minus 1. Now, right, what we want to express in terms of cos of 2 is this cos squared x. We want to get rid of it. So we put our 1 over to this side. We will have cos of 2x plus 1, this one here, is equal to 2 cos of cos squared x. Therefore, finally, cos squared x itself is equal to this divided by 2, which is half of cos of 2x plus a half. Right. So now, those are the results we are going to use to substitute for cos squared x and tan squared x. Remember, this is our cos squared x, so we can come here. Let me get rid of this, which is in the middle here. So what I will do now, let's have our equation written in full here. We have tan squared x plus sec cos squared x. Right, let's substitute tan squared x. We said it's sec squared x minus 1, so we have sec squared x minus 1. This cos squared x is equal to this part here, so we can say plus half of cos of 2x plus a half. Now, that gives us sec squared x plus this one here, half of cos of 2x minus 1 plus a half is equal to minus a half. We have proved the result. There we are. It's proof. It's proven. Excuse my English. Right. Now that we have proven the result, the next thing that we need to do now is to integrate this thing. Okay? We are always a little bit short of space, so every now and then we have to clear the board. So we don't need that, of course. We don't need all this. Right, it's saying here, integrate that. Let me write it over here. So it says integrate from 0 up to pi over 4 of tan squared x plus cos squared x with respect to x. But we have just proven here that this is equal to that. So we can replace this with that in the integral and write this is equal to the integral from 0 up to pi over 4 of sec squared x plus half of cos of 2x minus a half, all with respect to x. Okay? With respect to x. Of course, this can all be written as this is pretty simple. We know that the integral of sec squared x is equal to tan of x. So we have here, this will be tan of x. It's a standard integral. Plus here, it's 1 over 4 sine of 2x. Here, it's minus 1 over 2x. We are integrating from 0 up to pi over 4. Let's evaluate. Sorry, this should be 0. Let's evaluate the integral. Well, tan of pi over 4 is 1. It's tan of 45 degrees. Now, when x is equal to pi over 4, 2x is equal to pi over 2. Sine of pi over 2 is 1 multiplied by 1/4, it's 1 over 4, minus, this is just pi over 4. When x is pi over 4, half of it is pi over 8. And this we can simplify as 5 over 4 minus pi over 8. Let's put everything under one denominator. That will be 8. This will become a 10, so it becomes 1 over 8 brackets 10 minus pi. That's the integral. Let's put it somewhere where it's well kept, because we might actually, we're going to need it somewhere there in question B. So I will write this one here, 1 over 8 brackets 10 minus pi. Let's remember that's the integral of this thing here. Right. The question goes on to say, find the volume of the solid produced when the region shaded in green is rotated about the x-axis. Let me draw again our little sketch. It was this. There's your axis there. There's your y-axis there. And it was looking something like this. Okay, so that will be your graph of, and this is given as y is equal to tan of x. Oh, where is it going to fit? Let me put it somewhere on top there. So this will be y is equal to tan x plus cos of x. I'm a bit short of space there. So, and the region was from there, pi over 4, from 0 here to pi over 4, and it's this whole region there. So the question is saying, find the volume of solid produced when the region shaded in green is rotated about the x-axis. I didn't write all that because of space. So the question was actually saying the region bounded by y is equal to tan of x plus cos of x, the y-axis, the x-axis, and the line x is equal to pi over 4, and so forth and so forth. But I just summarized it and put it in this form. But that's the story there. You have got this graph here, and the line x is equal to pi over 4, and the line x is equal to 0, which is the y-axis, and this x-axis bounding the region. Now you want to revolve the region about the x-axis. What is the volume of the solid so produced? Right. Okay, let's clear our board first of all. How do you calculate the solid of revolution? It's just a nice and neat formula. So when you have your graph there, y is equal to f of x, something like that, the solid of revolution produced when this is rotated about the x-axis from a point a is equal, x is equal to a up to x is equal to b, is given by the volume is equal to the integral of pi multiplied by y squared, or with respect to x, from a to b. In this case, of course, our a is equal to 0, our b is equal to pi over 4. What is our y in this case? Our y is equal to tan of x plus cos of x. So let's put out the pi so we can factor out our pi and say this is equal to, from 0 here up to pi over 4, y squared is equal to that, which is equal to tan of x plus cos of x all squared with respect to x. Let's square this. This becomes pi integral from 0 up to pi over 4 of tan squared x plus 2 tan of x cos of x plus cos squared x with respect to x. Do you agree with that? When you expand this, remove the bracket, you get tan squared 2 tan of x plus that. Right, let's simplify. This again is equal to pi integral from 0 up to pi over 4 of tan squared x, which is this one, plus my cos squared x, which is that one. And this one can be simplified to, let's just perform a little calculation there to save time. Tan of x, of course, we know it's, so this will be 2 sine x over cos of x for my tan of x, multiplied, of course, by this cos of x. And the cos cancels out, and I'm left here with just a 2 sine of x, or with respect to x. But wait a minute, this here is what we just calculated here. So instead of all this, we can just put that and multiply it by pi, because everybody is multiplied by pi here. So let's do that and see what happens. So we now have, this becomes pi multiplied by this one here, which is pi, it becomes pi over 8, isn't it? Pi over 8, 10 minus pi. Let's just check that we did the right thing. We are saying this here is the same as that, which gave us that. It's the same limits from 0 up to pi over 4. Sorry, I wrote that. From 0 up to pi over 4. So it just gives us that. The only difference is that this time we are multiplying it by pi. So that's why I've got it like that. So all we need to deal with is this. So it becomes pi, our pi of course remains, pi integral of 2 sine of x dx. Okay, so let's take out the, what is integral sine of x? So it becomes pi over 8, 10 minus pi plus 2 pi from 0 up to pi over 4. Sorry, we should write it here. Pi over 4 of our sine of x with respect to x. Okay? It's clear again now, boys. We're coming down the home stretch now. Okay? What is integral of sine of x? It's minus cos of x. So this becomes pi over 8 bracket 10 minus pi. Oh, sorry, a bracket there. Bracket. Now this becomes a minus 2 pi multiplied by cos of x. Cos of x evaluated from 0 up to pi over 4. Okay? So, okay, let's do it slowly. This is pi over 8, 10 minus pi, minus 2 pi, brackets. When pi is equal to pi over, when x is equal to pi over 4, this one is equal to the root of 2 over 2. The cosine of 45 degrees. Of course, when x is equal to 0, that one will be equal to 1. Okay? Of course, now we can remove the brackets, and here we can remove the brackets and say this is equal to pi over 8 bracket 10 minus pi bracket minus this 2 and that 2 cancels, minus pi root of 2 That becomes a plus 2 pi. Of course, one can punch in these numbers into your calculator and get an exact value as required by the examiner. But that's the solution to problem 7, part B. The important thing, as you have seen here, the reason why we were putting all these things is to remind us of the issues that we need to deal with, the concepts that are running in the background, if you like. We have to prove the identity. Of course, you have to memorize some of the identities and your integral here. And the last thing, of course, was to calculate the solid of revolution. That's it for today. Till we see you in the next video. Thank you very much indeed.